This question given in GATE 2014 session 1 EC paper. Question is, in the following circuit employing pass transistor logic, all NMOS transistors are identical with a threshold voltage of 1 volt. Ignoring the body effect, the output voltage is at P, Q and R. So we need to find out what is the output voltages P and at node Q and at node R. The information related to pass transistor logic can be found in this following NPTEL course, CMOS Digital VLSI Design by Professor Sudeb Das Gupta, Department of Electronics and Communication Engineering, IIT, Roorkee. Before going to solve this problem, first we need to understand the information, the operation of a pass transistor logic. Suppose if I assume a pass transistor like this is gate terminal and this is source terminal and this is drain terminal. I will assume some load capacitance at this drain terminal. When gate voltage is 0 volts, okay, that means this NMOS transistor is off. That means there is no physical connection between source and drain terminal. So whatever the voltage across this capacitance will retain. That means if the previous voltage is 0 volts, so it will retain the 0 volts. So suppose if it is previous value is 5 volts, that means voltage across this capacitance is 5 volts, so it will retain the 5 volts. If a positive voltage VDD applied at the gate terminal, if input voltage is 0 volts, when a positive voltage applied at the gate terminal, we know that this transistor is on, that means a low resistive path exists across between these two terminals. So whatever the voltage or charge stored in these capacitors will simply discharge through this transistor. That means here the output voltage will be 0 volts. Suppose we will apply VDD at the source terminal. Okay, that means this transistor is on, a small resistive path exists between this drain and source terminal. So there is some load capacitance I will assume here. Okay, now the role of this source and drain will be reverse. Now this is acts like a drain terminal, now this is acts like a source terminal. Okay, so we know that a minimum of VT voltage should appear across source and gate and source terminal. To make this transistor on, a minimum of threshold voltage should be applied across gate and source terminal. So this capacitor will charge up to VDD minus VT. At this drain terminal we already applied VDD. Okay, at the gate terminal also we applied VDD. So this capacitor charge until the voltage is VDD minus VT. From this we can understood that when gate voltage is VDD and here when VDD voltage is applied, so at this output we will a VDD minus VT will appear. So from the previous discussion we know that when a positive voltage applied at the gate terminal, okay, here 5 volts is, here also 5 volts is applied. That means here at this point P, VDD minus VT. So in the question the threshold voltage is given as 1 volt. That means 5 minus 1. That means 4 volts appear at this terminal. Now this voltage is 4 volts. Okay. Again, this transistor 2 is also on because 5 volts is applied across this gate terminal. Okay. So that means this output capacitance, that means the capacitance here will charge to 4 volts. Similarly, this transistor 3 is also on because a positive voltage applied at gate terminal. That means this output capacitance will be charged to 4 volts. That means voltage at this node R is also 4 volts. So here P is 4 volts and Q is also 4 volts and R is also 4 volts. So option C is right choice.